Hello, today we're going to be talking about the Algebra 1 January 2018 Regents exam. Once again, I'm starting with a cleared graphing calculator, and my previous videos, I believe, are in this playlist. So, moving along, we are going to be working on example number 18. If the pattern continues, which equation or equations is a recursive formula that represents the number of squares in the sequence? So the idea is a recursive formula. So that should lead your eyes to choices 3 or choices 4. So I'm going to plug in the pattern and determine which one of these is correct. So if we take a look at choice 3, it's telling me that the first term is 3, or the first number in the sequence, the answer is 3. So design 1 represents A1, and I have 3 squares. Is that true? Yes. If we take a look at choice 4, it says my first term is 1. Is that true? No. So right off the bat, choice 4 isn't the answer. This has to be because if a recursive formula means I'm using the number before. So if I just say I want to find out design number 3, that would be A3 equals A sub 3 minus 1, because N is the stage number, and this is stage number 3. And then I'm going to add 2. So notice, when I plug in 3, it's actually asking me for term 2, because A3 minus 1 is really A2, which is the amount I get from design 2, which is 1, 2, 3, 4, 5. So this really becomes 5 plus 2, which is 7. So I have to use the number before to add to this stage. So I wind up with 7. So the answer is 3. For number 19, if the original function is shifted to the left 3 to make the function g of x, which expression would represent g of x? Okay, so you can start by plugging this into y1 and verifying which one of these will shift it left, or understand that shifting something left actually means you have to add 3 to the x value. So I'm going to have x plus 3 squared minus 1 is going to be our answer. We can verify this just by taking a look at our graphing calculator. So let's go to y1. We're going to type in 2x squared minus 1. And let's try choice 1. 2 parentheses x minus 3 squared minus 1. Let's take a look at the graph. Now remember, the order in which you have this plugged in is going to graph first. So I should see y1 being plotted first, and then following will be y2. So y1 graphed as follows. That's our original. And y2 was shifted to the right. We don't want it shifted to the right. We want it shifted to the left. So I'm going to go back to y equals, change y2 to be 2 times x plus 3 squared minus 1. And then I take a look at the graph. Once again, this is y1. Now let's see where the second one is plotted. To the left 3. That's what I'm looking for. You can verify that the other two do not work by typing them in. Once again, your first one's going to graph, and then you're looking to see where it shifts. And this one actually shifts up, so that's not what we're looking for in this example. And the last one will actually shift down. All right, let's take a look at number 20. First, consider the system. I have a system of equations here. And then consider the system of inequalities. When comparing the number of solutions in each of the systems, which statement is true? Well, these are 2 lines. You can actually take a look at what they look like in the graphing calculator. So I'm going to type this in. Negative alpha y equals enter. If you have an updated calculator, we'll get you a fraction. And then then I'll continue typing this in. I wind up with an x plus 1 and then x minus 5 here. If I look at the graph, you'll see that they wind up intersecting somewhere over here once. So that is the only solution that will make both equations true, because they have one intersection point right here, right? If this is our x-axis and y and x-axis. When you have a system of inequalities, the idea is that when you graph it, this is what the first one will look like. And then I have to graph the second one. You will have a double shaded area that represents all of your possible solutions. So I have an infinite amount of answers here because they're all in this double shaded solution. So the answer is choice 3, the system of inequalities has more solutions. Okay, so let's take a look at number 21. Nora inherited a savings account that was started by her grandmother 25 years ago. This scenario is modeled by the function right here, where A of t represents the value of the account in dollars, t years after inheritance, which function below is equivalent to. So that means I can type the original into y1 and all of these into y2 to determine if their tables are the same, because if their tables are the same, then they are equivalent. So I'm going to go to y equals. Be very careful how you're typing this in. So this is 5,000 times 1.013 to the x plus 25. That's our original for y1. And we're going to test each one of these to determine if they are correct or not. So the first one is going to be 5,000 times another parentheses, 1.013 to the x, close the parentheses, put another parentheses, and to the 25th. I'm going to double check second window to make sure I'm in auto mode because I want to automatically populate all of the x values in my table. And then I take a look at the table and they do not match. Okay, just to save time, the rest are not going to match until you get to number 4. In which I'm going to type that one in, 5,000 times 1.013 to the x times 1.013 to the 25th. If we look at the table, you will wind up with the same exact y and y1 and y2 every time you plug in an x value. So our answer is choice 4. If you take a look at example number 22, we once again are asking the value that makes it true is. So this is going to be y1. This can be y2, because here are the x values I will plug into both sides of the equation to determine if these x values make them true. So I can go into y equals. I'm going to type in alpha y equals enter. That's how I get the fraction. And just type it in exactly as is for y1. Then I go to y2, do the same thing. Alpha y equals enter will allow me to type in a fraction. And then the rest of the equation. So I want this to be in ask mode because I need to type in these choices, especially when I get to these decimals. So I'm going to go to second window, put this in ask, and then go to the table. Now I can type in -10, enter, and determine this value of -10 does not make it true, because if I plug it into the left side, I wind up with -3. When I plug it into the right side, I wind up with -43 over 15, and they are not equal. So then I'm going to try -2, and then I wind up with something that is not equal as well. When you get to these two choices, you'll see that there's a bar on the top that represents that this is repeating. So this same pattern of 09090909 goes on forever, and the same thing with the 3s. So when you type them in, you can type them, you'll get more and more accurate the more and more 09s you type in. So this is -9.0909090909. I do a couple of them and realize I'm pretty close. And then I type in -11.33333333, and I wind up with something that is exactly the same. So this is the value that when I plug into the equation will make them both true. You can actually solve it and so on. For my purposes today, I'm just showing you the best way using the graphing calculator to answer the questions. Sorry about that. For number 23, which quadratic function has the largest maximum over the set of real numbers? So we want to know the largest max. So I'm going to plug this into the graphing calculator and take a look at the graph to see what happens. So -x squared plus 2x plus 4 can go to the graph. and I see that I approach, I'm not quite sure what this value is exactly, so I can actually go to the calc function, so I can press second trace and determine, well, I know it's at the top of my function, so I know it's a maximum, so I'm going to calculate it. It asks you for the left bound and then the right bound. So basically, how far left do you want me to look for this maximum? So you need something a little bit to the left of it, which is about there, and then I can scroll to the right, because it asks you for right bound, so maybe a little bit further. I press enter. Do you want the calculator to guess between here and here for the maximum value? Yes. And you wind up with a maximum at x equals 1, y equals 5. So your max height in this example is 5. So let's take a look for g. G is going to be negative x minus 5 squared plus 5. Do the same thing. Take a look at the graph. And again, I'm pretty close up there. I'm not sure exactly where. So second trace gets me to the calc function. I press choice 5, which is the maximum. It's asking me for the left and right bounds. So you'll notice I couldn't see my cursor at first, so I just used scroll to the right. A little bit to the left is about there. I'll press enter, scroll to the right, press enter again, and it tells me once again that my y value is 5. So obviously, choices 1 and 3 are not the answer because it says which one has the largest maximum. They are the same, and I can't pick two choices for my answer. So now I'm going to have to take a look at these two tables. So from negative 1 to 3 to 5 to some point and then back down again, whereas here I go all the way up to 3, maybe a little bit more, and back down again. So the idea is the answer is choice 2, because when I'm graphing this, right, I'm going to hit 5 and 5, but I still have to do that turnaround. So I'm still going to have to go a little bit further than 5 and then come back down again. So that's why the best answer is choice 2. All right, and the last multiple choice question is number 24. It's quite a lot to read, so if you'd like to pause and read it quickly before I go forward, that's fine. Oh, sorry about that. So, voting rates in presidential elections from 1996 to 2012 are modeled below. So I see 4 different lines. They represent the different age groups that they polled, and this represents the percent over time. Which statement does not correctly interpret voting rates by age based on the given graph? So for citizens between 18 and 29, so that's them right here, the rate of change in the voting rate was greatest between 2000 and 2004. Well, that's true. It has the steepest line. So this is a true statement. From 1996 to 2012, so that's the entire length, the average rate of change was positive for only 2 age groups. Well, that's not true. It was positive for 3 of them, from 69 to 72, from 56 to 59, from 39 to 45. So this is a false statement. Choice 3, about 70% of people 45 and older voted in the 2004 election. 2004, we're looking at the people of 45, about 70. Yep, that sounds about right. And the voting rates of eligible age groups lies between 35 and 75% during the election every 4 years. So correct, because here's about 35 and here's about 75, and they all do lie within that realm. So that's also true. So our answer is choice 2. Thank you very much, and I hope you enjoyed watching. The next video should be on the constructed response. Thank you very much. Have a nice day.